I'm with Avanade at the Toronto studio, and today I'll be talking about Azure Cognitive Service, specifically on Lewis. Does anyone use Lewis in the room? Some of you guys have. How many developers do we have also in the room? Okay, so quite a bit. Okay, because this is a technical deck. So we'll talk about Lewis, talk about kind of why it's hard to do natural language processing. We'll go right into the basic building blocks of Lewis, kind of what are intents, entities, utterances, and then we'll spend most of the time talking about how to improve our model accuracy, which generally you spend the most time doing when you're doing models. We'll talk about best practices, and then I have a few good learning resources for anyone that wants to try it out or wants to continue learning at the end. So natural language processing, there's a couple reasons why it's very hard. Most of you probably learned a second language or even the first language. There's a lot of sentences that are very similar that can mean very different things, and there's a lot of sentences that are very different that can actually mean the same thing. So it's very challenging to programmatically come up with a solution that would, best fit all. On top of that, it's also really hard to create a solution for one domain and have pieces you can reuse for the next domain. This is what makes it quite expensive to create a natural language processing solutions, and that's something that Lewis is trying to make easier for us. So generally your Lewis model, from a very top-down view, you create utterances to train the model, you create a domain, something that you want to tackle, whether it be booking flights, booking hotels, whatever you want to do. And you give it examples and you start training it. You have Lewis intents that you're trying to get back from the model. You say, okay, here's input, and I want my model, tell me I want to book a hotel from this date to this date in this location. Then you deploy that model to the endpoint. Azure will take care of this all for you. And you start getting sample data in. You start looking at it, you start maintaining your model, you start seeing utterances that you're doing well, and utterances you're not doing so well at. And you kind of go back to the drawing board, you tweak your model, and it's an iterative process, over and over again, trying to tweak it to get better and better. So we see Lewis in many different areas, primarily in chatbots or virtual assistants in natural language processing, but we're also seeing a lot of IoT. And you can do things like get Lewis to open your fridge, make your coffee, turn on your lights, anything with a microphone. You can plug in the IoT device, and as long as your model is behaving properly, you can actually talk to it. So these are kind of the areas that we see a lot of traction. But let's kind of dive into how Lewis starts working. So the first thing is kind of the basics. You have the domain. So the domain is really important. This is kind of the application context your wish to challenge or your wish to conquer. So let's say we're doing a hotel booking system. So we want a model to understand all the utterances or all the inputs or all the text that would make sense in that world. So if I want to book a hotel, if I want to locate a hotel has a vacancy, these are all the types of sentences my model should be understanding. And so it's very important to build your domain. What's in your domain and what's not in your domain are very important things. So there is a none intent, which we'll get to in a second, that tells our model this has nothing to do with what we're trying to challenge. Our model should respond to this, and we give it kind of the none intent. There's also a lot of pre-built domains that we can leverage from Lewis, and we can build a custom domain on top of that, which we call hybrids. And so we don't always start pretty much from ground up every time. So I said things like utterances, intents, and entities. And basically, an utterance is just a sentence that we expect our model to interpret. Intents are something that we expect, so we have predefined intents in our model, and that's kind of like what we want to do and what we expect to have returned from us by the model. So book a flight could be an intent, and we can expect to have input parameters like date, the from destination, the to destination. We have entities, and entities are physical, real-world objects and data points that we want our model to consume. So if I say, book me a flight from Cairo to Paris, I'm expecting my entities to be Cairo, Paris as a location. I'm expecting my book a flight intent to pop up. And basically, I give my model utterances, and I expect the right intents to fire. And we'll go into these in specifics. So intents, utterances should be mapped into intents. Here's some basic examples. Booking a flight to Montreal tomorrow. If we had a book flight intent, that's what we would expect our model to return with. If we have, hi, hello, good morning, we're doing more of a chatbot, and we program a greeting intent, we would expect that the application, the middleware, receive the greeting intent from our model. Check weather, cancel flight, and for example, the none intent. When will the Leafs win a cup? What's those lucky lottery numbers? Things that we expect our model to return, saying, hey, I have no idea what this is, I don't want to know what this isn't what I've been programmed to do. It's really, really important that you give a lot of examples to your none intent, as your application can start doing really funky things if it's not programmed properly. So here's an example of kind of an intent workflow. You have your business level domain, so you have conference management, let's say we have an application. You have your top business intents. As these aren't loose intents, these are something that's particular to the application. So we have booking information, general QA, and our application, our middleware would understand what that is. And then we programmed or we modeled kind of our Lewis intent to get us there. So we have, we want to make a booking, we want to reset our password, whatever it is, this is what we expect Lewis to return us with, as well as the none intent. So when we give utterances or we give examples of text, this is kind of what our model should look like. It should give us that general QA questions if there's, a simple QA question being inputted. We should get agenda if someone wants to know kind of what's going on in the hotel. That's kind of how we want to design. We want to have like a business layer intent that are categorized that you handle through code, and then you want to have your Lewis intents that kind of break that problem down. So entities, kind of like what I mentioned, are the physical nouns that we wish to pick up. So here's a couple examples from, I think, one of our boot camps out in Toronto. Set up a meeting between person and myself. Book a meeting with person. Person would be an entity that you create in your model. When the utterance comes in, that would be a name. Book a meeting with Carl and myself, or Bob, or whomever. And you would expect your model to understand that name maps to that entity. And we'll get into entity types, some designing patterns with entities. A lot of time is spent on getting the right entities to fire and kind of designing the correct entities. So we have a few entity types, and there's a few more that I'll get to later, but the first one is like the simple one. Book a flight on Canada Air or Air Canada. You would expect to have an airline, let's say, entity that would pick up Air Canada. So if it was Air France, if it was Cathay Pacific, or whatever their airline, the model starts learning that these nouns are really kind of grouped together. When it learns from one simple entity, it will apply to the other. We have list entities that are kind of exact matches. So these are really good for keeping the airspace domain. Like let's say we had a list, a hard-coded list of all the airports. YYZ, Billy Bishop, YYZ, like all of the possible combinations of airports, we could put that in a list entity, and our model will start picking that up. So every time one of those exact texts come in, it would match with our list entity. We have hierarchical, which are kind of parent-child relationship. These are good for, let's say we had a travel class. So we had business class, middle class, and economy, or premium economy and economy. So we could say, while we understand that these children classes are different, or these entities are different, they all represent the same thing to our application or to our model. So that would be a good idea of a hierarchical class, or a hierarchical entity type. Composite kind of takes that, makes it a little bit more complicated, or a composite, and then we'll get into examples later. I just kind of going through a little bit of the definitions. Composite, you don't have to always have simple entity types as children. So you can have a number, you can use a pre-built, you can use composites and composites. The pre-built ones are ones that come for free with Lewis. Number, date, time, there's a whole bunch we can use, and we use them all the time. And then the last is the regular expression, which isn't really machine learning, but if you know, I don't know, let's say you're in manufacturing and you know the acronyms that you're going to work with, and you say, you know what, I don't want the model to really pick these up, I'm going to hard code what the regular expression is going to look like, you can kind of put them in there, and then the Lewis model will just take your word for it and match them. So here's another couple examples of the big ones. On the left, we have like a simple one where we map the top sentence would be what kind of comes into the endpoint or what we train it with, and the second one would be kind of what we expect our model to map to. List, kind of the airport ones that I mentioned. So if anything comes, those are kind of weird airports, but any of those come in, we have an exact match. Hierarchical, kind of the travel classes I mentioned, and these are important because, let's say economies, if you say something like, book me the cheapest flight to Montreal, you might want to train your economy simple entity to say, okay, cheapest, even though it's not the word economy, it's not, if I don't say what class I want, I'm assuming it's going to be economy, and if I say cheapest or what's the lowest price, I want to train it so it understands that's economy. But I don't necessarily want to train it with the travel class. It'll start understanding these separately, but in my application, I want to kind of input travel class, because when I go to the middleware, I don't really care if it's first, business, or economy. I need to book the ticket, or I need to provide an API to book the ticket. Composite is kind of expanding on that subject. It's, book 2 adult business tickets. If you have a good model for understanding the travel class, you can put that as your ticket order entity, and you can have that get passed back to your middleware. So these are kind of all the tools we use for entity types, and we need to pair them up with really good utterances so our model starts picking them up. And as I mentioned, improving accuracy is kind of the hard part of this. And there's 3 things that are challenging always when it comes to Lewis models. The first is getting the right utterances. Getting the right amount of utterances, the right order. You don't want to give too many utterances of the same thing. Book me a flight today, book me a flight tomorrow. That's not really helping the model. You want to saturate with one pattern. The next thing is getting your model to return you the correct intent. And so do you want to book a flight, or do you want to book a hotel? Do you want to create a coffee? So whatever you design the model to turn back, is your model actually predicting that correctly? And the third one is the entities. Is your model collecting the entities correctly? And there are strategies that we can leverage to help our model train each of those 3. The first thing we look at are the prediction scores. And this is something that's provided by Lewis. This is telling us, we go through and we can look at all the utterances on our endpoint as well as the utterances that we train the model with. And it'll tell us what's the top scoring intent, so which one did it predict at the highest, what that percentage was, and what entities did it pick up. And so anything less than 90 is not good. So if your top scoring intent is less than 90% or even less than 95, you got some work to do to get that more accurate. This is where you're going to spend a lot of time kind of reviewing scores, seeing what's working, what's not working, and tweaking. Yes, sir?
How do you handle language detection?
The language detection, Lewis has multiple languages you can put in there, but if it's not supported, you'll have to translate it before you hit the endpoint. Yeah.
Is there something similar to BaseNet but for speech recognition?
So Lewis is just a natural language processing. There is translator and there is speech to text and all that you can use before, but you have to provide it in text format when you get to Lewis. And Azure Cognitive Services have one that goes speech to text if you need it. Any other questions? Okay. So the first kind of strategy we can use is the simplest, what's called active learning. So Lewis by default will provide you a list of utterances that it did poorly on in your endpoint. So there's 2 criteria that will land an utterance there. If the top scoring intent is low, it will place it there. And the second big problem is if your top scoring intent was high enough, let's say, but your second scoring intent was just as high, if you had, let's say, a 95 and then like an 87 as your second one, that's also a problem. You want a big disparity between your top level intent and your second level intent, which means that you're matching too much. These 2 intents are too close, and the model doesn't really understand the differences between them. So active learning is a manual process where you'll go in, you'll look at all the utterances you did poorly on, you'll manually put in, okay, this was supposed to be this intent, this entity type was supposed to be this entity type, or you failed at recognizing Ryan as a name, and you put the person name manually, and then you retrain your model, and hopefully it gets better at those utterances. It is a manual process, but it is the easiest one to go with, and it's really good to review this regularly as a maintenance cycle. So if you're using Agile, sprint review, go through them, see what's going well, see what's not going well. Iterative waterfall, I don't know how that plays in too much. These are mainly done in agile environments, but it's an iterative process. The second one is a phrase list, and for the machine learning folks, this is basically Lewis's version of a feature, where you provide extra information. Now, a feature and a phrase list, they're not entities, so these are not intents, these are not entities, but these are like suggestive hints that you're saying. You're pretty much telling Lewis, hey, these words, there's some similarity between them, and I want you to apply what you learned about any one of these words together. And you're kind of helping Lewis to understand. So for example, names is a really good one. You could use an entity list, a hard code name, you'll never find a complete list of names. But if you provided a phrase list, you can say, hey, these are the names, all these names are there's something in common with all these pieces of text, and I want you to start learning it together. So when you learn about one, you learn about the other. Where they're placed in the sentence, are they close to verbs, or are pronouns being acted on them, whatever it is. And there's two types of phrase lists. There's interchangeable, and non-interchangeable. And interchangeable are synonyms. So let's say you have an application that doesn't really care what type of fruit it is, but cares that it's a fruit. So you can say, here's a whole bunch of lists of fruits, and I want them to be acted like synonyms. So you can kind of swap one for the other. Another example of a non-interchangeable, something interchangeable, a non-interchangeable are like words, but that you can't really treat them as synonyms. So proprietary words, acronyms, let's say you're in manufacturing again, and there's a lot of acronyms, and you want your model to learn them or identify them, but they're not interchangeable. One can't replace the other, and maybe you have other entities that want to get picked up. So you can start telling it, these are a list of words that don't mean the same thing, but I want you to learn them together. So that would be a good example of non-interchangeable phrase lists. And then you have Lewis has suggestions. So when you're putting in your phrase list, it'll actually suggest a whole bunch. So you start putting in, you start putting in lemon, apple, tomato, it'll pick it up and be like, oh, here's an actual whole list of fruits that we have learned previously, and you can just ask it and it'll add it to your phrase list. And we can look into that in more detail. One of the things, so they're very similar to list entities, and the biggest difference between list entity and a phrase list is how much you know. If you have for example, you have food items on a menu, you know exactly all your food items. You have a complete list of every noun that can possibly be said or possibly be entered. So that's a really good example of something you want to do as a list entity. If you have names, for example, you can provide a lot of sample names, but you'll never get the complete list of names. So you want to be really careful when you use list entities and when you use phrase lists, because they don't replace each other. So it all depends on what you know about the data, how your model is performing, and kind of what are the utterances you're trying to solve. Another technique is patterns. So patterns helps us solve problems when our intent score is low. It doesn't really help us very much with entities, but it helps us with when our model is not picking the right intent. And the first thing we do with patterns is we understand that there's an importance in the order of the sentence. So if we're booking a flight, for example, from one place to the other, we start understanding that usually we're going to say the destination entity first, and then the source destination, or the origin, let's say the other way around. We have to understand the origin entity comes first, and then we say, if I'm saying from somewhere to something, I'm starting to tell Lewis, hey, I understand this pattern. There's a pattern, there's a template on this string that I'm trying to interpret. And if you see this kind of format, here's another hint that we're trying to book a flight. And what we can do is, with patterns, we can add roles to entities that are only exclusive in patterns. And so here we have location origin. So location would be our entity. And we put, hey, I know that if this one comes first, I'm going to label this as an origin. And if this one comes, and if I have another one, I'm going to label it as a destination. So that's a manually inputted role that we put on those entities to help us understand that we want to book a flight. And that there might be probably two locations And if there's two, we probably want to book a flight. If there's not, we might get another intent. What's the weather like in Cairo, for example? Maybe that's not book a flight. But if we have two locations in this kind of formatted text, most likely we want to book a flight. So we're, again, trying to help Lewis pick the right intent. With patterns, we have a very special case, which is a separate entity that wasn't on my original list, which is patterns.any. And with this entity, basically with the template or the order of the sentence, what we can say is, hey, this entity might have a very different length. It can have one letter, and it can be an entire sentence. But I want you to treat that as one block, one entity. So a really good example for patterns.any is like the book of a title, right? You can have a really long title, or you can have a really short title. But if you say, how much does book title cost, for example, if it sees how much does, and it starts learning on it, it'll try to put the remaining text into one entity. So I can say, hey, this is an actual book title. Don't try to understand, the curious incident of the dog in the night. So that's another tool we have on our tool belt to kind of help us deal with names, proper names, or anything that really varies a lot in length, as those are very challenging entities to try to solve. So some best practices. The first one that comes to mind is the none intent. Super important that you spend like 15 to 20% of all your utterances should be training your none intent. And as a reminder, your none intent is you're training your model to understand that anything that matches those utterances that you've trained it to do not belong in the domain of your model. So it's not supposed to find entities, it's not supposed to find the intents. Means that if you have a model to order a coffee and you talk about coffee, like it should not fire. None of those, it shouldn't learn anything from that utterance. The only thing it should learn is, this has nothing to do with my domain. Another one is, what we find very difficult is when you have two top scoring intents. So let's say book a hotel is an intent that I programmed, and book a flight, right? So a lot of my utterances that I sample for book hotel, book flight, are going to be very similar. Book on this date, book a flight on that date, book a hotel here, book a flight from here to there. So when you have two top scoring intents, sometimes what you want to do is actually merge them and say, you know what, let's bring this together, book something, and then train the model to pick up the correct entities between a hotel and a flight, for example. So you don't want to be too generic, but you don't want to be too specific also on your intents as they can merge. Another big one is I wouldn't use phrase lists and patterns right away. I would try to use list entities, get off the ground going, see how your model's doing, and only when you start really getting into these corner cases where your model's performing poorly, really start bringing in the other improving factors, as it can be quite difficult to get it right the first time. And the main thing is that it's an iterative approach, so you don't want to design 4 intents off the bat. You want to design one, get it working, get it to understand your intent properly, and then add another one. And then do that, see how they both work together, and then add a third one. Also, this one at the top right, with utterances, be very careful how many utterances you train that are in the same format. They're really scaling. You're impacting the learning of the model by saying, book me a flight to Japan, book me a flight to Paris, book me a flight to Montreal. Those are the same format sentences, and if you provide those training utterances over and over again, it's going to start learning things it shouldn't, whereas it's really starting to respect that format for that intent. And anytime you actually do want to book a flight somewhere else, it's going to say, well, it's not this format that you've given me, so it's going to have a low scoring intent. So you want to really vary as much as you can with your utterances. And last but not least, we have to show you some really good documentation on Lewis. This is they go through the documentation and they give you samples, and you can pull these down. It's right on GitHub. You can bring them right into your Lewis model, download them, and play around with them and see where a model is. For example, phrase lists are good with entities. Here's a model that has some certain utterances, and you're not picking up, this one entity that you define. And it'll tell you well, if you replace this list entity with a phrase list, here's how your model behaves better. So they have really singled out separate problems with solutions, and you can kind of tinker around and see why it's working, and you can play with it. So I would really encourage anyone to go to the samples as well. They also have container support, which is really, really cool. So you can get your model, you can containerize it, you can deploy it anywhere. That's relatively new. I haven't played around with it, but I highly suggest anyone to. I don't really know how that works with the pricing model though. That could be a question for the Microsoft people. I don't know if there's any in the room, but. Yeah, do you know, because these services you pay per hit on the endpoints.
Yeah.
So when you containerize it and you take it offline, how does the pricing model work?
You still need to have connections.
Okay.
Crunch time, and after that you'll send just like kind of like your usage, information about your usage. So you need to specify like your endpoint and also API key.
Right,
so
right,
it will
okay.
kind of send the usage and you still.
So the pricing model doesn't change. Okay, yeah, thanks. What else? And best practices. So there's a whole list of best practices explained in much more detail and what you should do and why you should do it. Also for testing, they recommend having so there's 3 types of utterances. There's the utterance you do to train your model. So you're trying to get your model to learn. There's the utterances that come from your endpoint, which is your user utterances that hit your endpoint, which are like live data or test data or whatever. And there's a set of utterances you should always keep that aren't trained that you kind of benchmark your model separately. So you have a list of sentences or a list of inputs that you know are pretty difficult to find. You train it, but you test it with those utterances, but you don't want to train it because you don't want to teach those specific things. You just want to leave those as like a benchmark for yourself to see kind of how you're doing. So they explain all that here, and it's a really good resource. I recommend anyone to go about and read it. It's very easy to kind of go on lewis.ai and start playing around with it. They have a lot of sample code, a lot of entities, and it's a lot of fun. That's it for me. Is there any questions?
How the integration to the backend works? Is it a function and how you can control the flow of the conversation?
Right. So in the bot framework, for example, so if you're plugged into bot framework, which I think is kind of question, you take your input, let's say it's from a website or from a chat bot or from a chat window, whatever. You hit Lewis's endpoint, and what you see is returned from the post or from the get would be the top scoring intent and any entities that come with it. So then your application would handle it.
Okay.
So Lewis would return you, book a flight and keep the entity like from location to location, and that would be a JSON response that you get back from Lewis.
Right.
When you're testing, and then your application would have to handle that however it handles it. Yeah.
Do you have any reference of commercial grade applications that are already using Lewis?
Yeah, there's I don't think I have them written down. Lewis is using them like a ton of virtual assistants, a ton of IoT stuff. I don't know exactly off the top of my head. We worked with Air Canada on it. If Bruno was here, I don't think he's here, but he would have more. Like it's there. I just don't have a list. Yeah. Yeah.
Does Lewis support any like contextual feature where it keeps track of previous conversation for you, or do you have to manage it?
It will tell you the poorly rated ones, and you can configure to do a whole bunch of things. But you should be saving. You should be you can look at it. It will dump all the utterances on the endpoint and what they're scored with, and you can kind of save that and back it up as you want. But mainly it provides default experience for like the bad ones. But yeah, you have a list of everything that hit it if you want it. Okay. Well, thanks guys.